In this lecture of signals and systems, today we will find Laplace transform of some standard signals. In this video, we will see how you can easily find the Laplace transform if you know this table. Or if you are given inverse Laplace transform, then also you can easily find the related signal to that spectrum. Starting with the first signal, we have u of t. Laplace transform of u of t is 1 divided by s. Coming to the ROC, we know that the denominator is equated to 0 in order to find the poles. So we have s is equal to 0. Now since u of t is a right-sided signal, we have ROC equal to real of s greater than 0. Second signal is t into u of t. Laplace transform of this signal is 1 divided by s square. Again, equating the denominator, we have s square equal to 0, that is s is equal to 0, and since this signal is accompanied with the right-sided signal u of t, we have ROC equal to real of s greater than 0. Third signal is t raised to n u of t. It gives the Laplace transform n factorial divided by s raised to n plus 1. For example, if we have t square u of t, Laplace transform of this signal is 2 factorial divided by s raised to 3. That is equal to 2 divided by s cube. Like that, if you have t raised to 3 u of t, it will give a Laplace transform 3 factorial divided by s raised to 4. That is equal to 6 divided by s raised to 4. So based on the power of t, you can get the answer of a Laplace transform. Now coming to the ROC, since t raised to n is multiplied with u of t term and u of t is a right-sided signal, again we will get real of s greater than 0. Fourth signal is e raised to at u of t. Laplace transform of this signal is 1 divided by s minus a. E raised to at is a growing exponential signal. So in order to find the pole, we need to equate the denominator s minus a to 0. So we get a pole equal to a. Since e raised to at is multiplied with a right-sided signal u of t, we get ROC equal to real of s greater than a. Our fifth signal is e raised to minus at u of t. For this, the Laplace transform is 1 divided by s plus a. E raised to minus at is a decaying exponential. Again, in order to find the pole, we need to equate the denominator to 0. So we are getting a pole equal to minus a. Since this signal is a right-sided signal, again we have real of s greater than minus a. Sixth signal is e raised to minus at u of minus t. Whenever we have a decaying exponential signal, we are getting a Laplace transform of it as 1 divided by s plus a. Now, in this signal, we have u of minus t instead of u of t. So that is the reason we need to attach one negative sign to this expression. So we are getting our Laplace transform as minus 1 divided by s plus a. Now the pole for this signal is equal to minus a. Since u of minus t is a left-sided signal, we have real of s less than minus a. Seventh signal is e raised to at u of minus t. Now the Laplace transform of e raised to at u of t is 1 divided by s minus a. And since we have u of minus t, we need to attach one negative sign to this, that is minus 1 divided by s minus a. Since u of minus t is a left-sided signal, we get real of s is less than a. Eighth signal is t into e raised to minus at into u of t. So here we are clubbing three functions together. We know what we have to do when t term is there, what we need to do when e raised to minus at term is there, and what we need to do when u of t term is there. Laplace transform of e raised to minus at is 1 divided by s plus a. When this exponential signal is multiplied with t, we know that the Laplace transform is 1 divided by s plus a square. Now, in order to find a pole, equate the denominator to 0, so we are getting pole equal to minus a. Since the signal is having u of t term, our real of s is greater than minus a. Ninth equation is t raised to n e raised to minus at u of t. As we know, e raised to minus at u of t is giving us a Laplace transform 1 divided by s plus a. Since t raised to n term is there, we are writing it as n factorial divided by s plus a raised to n plus 1. So, equating the denominator to 0, we are getting a pole equal to minus a. So, we have a region of convergence, that is real of s greater than minus a, since we have a u of t term in this equation. 10th signal is t into e raised to at u of t. Laplace transform of e raised to at u of t is 1 divided by s minus a. Since the signal is multiplied with t, we write it as 1 divided by s minus a square. Again, since it is a right-sided signal, we have real of s greater than a, where a is the pole of this spectrum. 11th expression is t raised to n e raised to at u of t. E raised to at u of t, again it gives Laplace transform 1 divided by s minus a. T raised to n is giving us a transform n factorial divided by s minus a n plus raised to n plus 1. And since this signal is having u of t term, we have real of s greater than a. Again, equating the denominator, we are getting a pole equal to a for this equation. 12th expression is t raised to n e raised to minus at u of minus t. Now the Laplace transform of e raised to minus at u of t is 1 divided by s plus a. Since u of minus t term is there, we need to add one negative sign to this spectrum. T raised to n term finally gives us the Laplace transform minus n factorial divided by s plus a raised to n plus 1. Since we have u of minus t, which is a left-sided signal, we get real of s is less than minus a. 13th expression is t raised to n e raised to at u of minus t. Laplace transform of e raised to at is 1 divided by s minus a. Since u of minus t term is there, we have to attach one negative sign for the transform. And because of t raised to n term, we are getting an expression for the transform equal to minus n factorial divided by s minus a raised to n plus 1. Now for the region of convergence, we have a pole of the transform at s is equal to a. So real of s is less than a, since this signal is having u of minus t term. Now the 14th expression is cos omega naught t u of t. Laplace transform of this signal is s divided by s square plus omega naught square. Here the pole is equal to 0, and since we have u of t term, we have real of s greater than 0 as the ROC of this signal. 15th equation is sin omega naught t u of t. For this, the Laplace transform is omega naught divided by s square plus omega naught square. Again here the pole is equal to 0, and since we have a u of t term, we get real of s greater than 0. 16th equation is e raised to minus at cos omega naught t u of t. Since we are multiplying e raised to minus at to cos term, instead of s in the 14th equation, we will be writing here s plus a divided by s plus a square plus omega naught square. Now in this case, we are getting a pole equal to minus a. And since we have u of t equation, we are getting ROC as real of s greater than minus a. 70th equation is e raised to minus at sin omega naught t u of t. So we have expression omega naught divided by, instead of s, now we will be writing it as s plus a square plus omega naught square. Here we are getting a pole again equal to minus a, and since we are multiplying this signal with u of t, we are getting real of s greater than minus a. So these are some of the shortcuts to solve Laplace transform. If you keep in mind the signals and the corresponding transforms, it will definitely help you to solve complex problems in Laplace transform. Thank you.